you see that right there, is a very powerful piece of math. You will use it in very, very many.
Can we borrow your stapler?
Yes.
We'll bring it back.
I'll be here.
Okay. I knew it. Okay.
I feel they made that much more awkward than it needed to be.
Yeah.
Can I borrow your stapler? Here you go. Oh. You just take the stapler and walk out. Right? What made that difficult? Anyways, proportional reasoning, you're going to use it in socials, you're going to use it in physics, you're going to use it in chemistry, you're going to use it in biology, you're going to use it in the grocery store when you're buying stuff to see if you're getting a good deal on it. You're going to use it if you have to convert money to go to another country. You're going to use this math all the time throughout the rest of your life. And it's very, very easy to do. We use proportional reasoning in order to convert units between different systems. And it always works the same. I'm going to use colors to do this. In black, whenever you need to convert any value, Canadian dollars to American dollars, liters of fuel to gallons of fuel, pounds to kilograms. Whenever you need to convert anything, you can do this. You start with a value. This is the value you want to convert. You always start, not to convent, you're not taking a value to the place where the nuns live. You have a value you want to convert. Whatever it is, it doesn't matter what it is. Money, volume of something, anything. It doesn't matter. And you multiply that. Thank you.
Thank you.
Significantly better. Way less awkward. Much better.
Wait, what's up with your stapler?
My stapler doesn't stay down anymore.
Whoa.
I don't know why.
New toys.
Anyways, and you multiply it by the following fraction. You multiply it by a fraction that is made up of the want, that's what you want to convert it to, over the value that you have. And this will always, always work. If I want to transfer Canadian dollars to American dollars, I am starting with Canadian dollars. I am multiplying it by a fraction that has American dollars over Canadian dollars. It seems weird until you actually do it. So, let's check this very first one. It's very easy. All of you can do it in your head, but we're going to write it out the long way, because even if you write the easy ones out, when you get to the difficult ones, you'll already know what to do. So, the first question says we are going to convert 485 centimeters to meters, which means I'm starting with 485 centimeters. That's in black, just like in my color-coded equation over here. Now I'm going to multiply. What do I want?
Meters.
I want meters, so meters goes in the numerator, and I have centimeters in the denominator. Now I need some numbers there, or I can't do any math. I get the numbers here. These numbers come from this chart. Okay? So all I do is I find them. Where are meters and centimeters? Right there. 1 meter. There's an M, so what number do I put there?
1 meter.
1. There is centimeters, so what cm, so what number do I write there? 100 cm, so I write 100 there. Now I just do this math. Now, 485, do we ever care about multiplying or dividing by 1? No, because it doesn't change the value, yes?
So it'd be 100.
So this disappears. My computer is frozen. We will give it a moment. We will give it a moment. We will give it a moment. There we go. The 1 disappears. And of course, since we are multiplying fractions, and we just did a whole sheet on that, we know that this 485 will now be in the numerator spot, and 100 will be in the denominator spot. And that is where we go to our calculator, if we need to. Now, since we're doing metric, we don't need to, do we? Because, one sec, when we divide by 100, we know the decimal is going to move how many places? 2. So the answer is 4.85 meters. Is everybody cool? And of course, you could have done that in your head. But like I say, if you learn the steps with the ones you can do in your head, when you get to the ones that you can't do in your head, you're already going to know how to do it. Everybody good? Questions? Ariana, go. Oh, okay. Well, what is actually happening here, and you don't need to write this down, this is 485, technically 485 over 1, right? Yeah. Okay. Times 1 over 100, right? And then when you're multiplying fractions, you can cancel both the ones because they're the same on the top and the bottom. And I'm left with 485 on the top in the numerator spot and 100 in the denominator spot. And then it's division. Cool? Everybody good? And that's all you do. Now, sometimes, even when you're staying in one system, it gets a little yucky. And I'll show you what happens on this very next one. The very next one is already going to be a yucky one. What is the value we are starting with? 57 inches. And what do I wish to convert it to? Feet. So what I want is feet over what I have is inches. Where do I get the numbers? From the chart. Where is it on the chart?
Here. Right here, the bottom of the
1 foot is 12 inches. So where does the 1 go? With the foot. And where does the 12 go? With the inches. Do I ever care about the 1? So we get rid of it, and I'm left with 57 over 12. Now, I hit that up with my calculator, and I get 4.75. Now, Jeremy.
Doing extra math, you can determine that if you subtract 1 inch by 1 inch by 1 inch, eventually you'll reach 48 feet and 9 inches.
You'll reach 44 feet, 9 inches, which is where I am about to go with this. Good call. Am I technically allowed to put 4.75 feet? No, why not? Imperial doesn't use decimals because it isn't based on 10, is it? So that is technically 4 3/4 of a foot, yes? But we don't measure feet in quarters, do we? We measure feet. What do feet break down into? We just did it. 12 inches, right? So 4 3/4 feet is 4 feet and 9/12, right? Or, as Jeremy said, 4 feet 9 inches. Now let's stop for a moment and look at that. Are all of these the exact same value?
Yep.
Yes. Are they all then, therefore, the right answer? Yes. Which is the one that we use in reality? 4'9".
Yeah.
Everybody understand? Like I am 5'7". I'm going to say 5'8" because it works out better. 8 out of 12, right? So I am technically 5.67 feet tall. Does anybody say that? No. Now you know how to sneeze. My sneezes were embarrassing compared to that. All right, everybody understand? All of them are okay. One of them gets you the A. Because one of them shows me you understand how the measurement system works. And that is this one. Now, here's the mistake you're going to make. What if I wrote 4.75 feet? Is that 4 feet 7 inches? No, because it's 4 feet 9 inches. Everybody cool? Other way around. I am 5 foot 8 inches tall. Am I 5.8 feet tall? No, because feet don't use decimals. Is everybody cool? Now, again, am I going to get too hung up on this? Or is this where I care your knowledge lies? I'm much more, let's get you on the left side of this to perfect, and then we'll worry about fixing it up properly on the right side. Is everybody good? Okay, so you all do number 3. Set it up properly, even though some of you have already done it in your head. Set it up properly, because when we get to the second half of today, being able to set it up is going to really help you. Go. It should take about 10 seconds. Yo.
When you convert centimeters to meters, can we just add a decimal to it?
Yeah, 2 decimals to it.
But there's only one in 4.85.
No, 4.85. That's 2 decimal places. Because we had 485, so we moved the decimal place 2 spots.
Okay.
If you can't remember how many feet are in a yard, you check on the sheet, and you find yards and feet. Not 15 divided by 3, Ariana. Because feet is what we want, so it's on the top. So we cross out the one that we don't want, and now we've got 2 numerators.
So then it would be, if we want yards, then we...
If it was the other way around, it would be divide.
How do we know when to do that?
That's why you follow this method. What you want is in the numerator spot. What you have is in the denominator spot. So when you read that question, I have yards, I want feet. So feet goes up top, yards goes on the bottom.
3 over 1.
Right? And then the 1 we get rid of, and now I've got 2 numerators. So it's 15 times 3. There's a reason I make you guys try that one on your own to see how many people do divide. That's also why I stress, set it up. And then when you set it up, you can't do it wrong. Yes. Ladies and gentlemen, I'm warning you right now, next week starts the following policy. You may go to the bathroom twice a week from my classroom. Twice a week you may leave my classroom. If you use them up on Monday and Tuesday, you are going nowhere on Wednesday, Thursday, Friday. How will you solve that problem? You will have a water bottle like Hannah has. You will fill it and you will be judicious with its use. You will pee in the 5 minutes you have between classes or before class or lunch when you have all morning and 40 minutes to pee. Because I get very tired of the endless parade to the washroom. Because I, too, was a teenager, and I know how many times I actually peed during class, which was never. I went to the washroom to get out of class, or because I saw my friend walking by, or nowadays because I got a little Instagram text, Snapchat, or tweet, or Facebook message, or WhatsApp, or any other way you talk to each other, and you are meeting them outside of the room. Do I make myself clear?
Yes.
Excellent. Pardon me? That was scary? That scared you? Holy crap. I'm going to have to very significantly change the way I talk to you people if that was scary.
What do you mean? Change it?
Obviously, I'm going to need to be very careful because if that scared you, that was on a scale of 1 to 100 of my anger that you may face. That was about 1.5.
It kind of it set me back because it came out of nowhere, but it didn't necessarily scare me because I have a mother at home who's very scary. So
Okay. So, Now that we have talked about both, ones where we divide and ones where we multiply, everybody try 4. 4, I'm warning you, is going to give you a hassle. So do what you know how to do, and then we'll talk about what the problem with it is. We have 136 feet. What am I going to?
Want yards.
I want yards, so yards is on top, feet is on the bottom. Go to your chart, 1 yard, 3 feet. We get rid of the 1, and I got 136 divided by 3.
The yard is
1 yard is 3 feet.
want, have,
Okay. Now, when you do this with your calculator, something weird is going to happen. What is going to happen? You're going to get 45.333, and that 3 is going to repeat. Is that right? Yes. Is it the best answer? No, because we all know that 0.333 is 1/3, yes?
yeah.
So we could say 45 and 1/3 of a yard. Am I at the best answer yet? No, because yards do break down into something, don't they? What do they break down into? Feet. And how many feet are in a yard? 3. So isn't 1/3 of a yard 1 foot? So what is the best answer here? 45 yards, 1 foot. Again, do I necessarily care? Now the question becomes, how do I differentiate between a kid that can do the calculator work, which gets them to there, and a kid that can do that work, which is obviously the best answer? They are both right, but they obviously show a different level of thinking, don't they? And what should I, as a teacher, be rewarding? The ability to punch stuff into a calculator? Or the ability to think of what it actually means? Think of what it actually means. But that being said, if you get the blue answer, are you failing Math 10?
No.
Of course not. But if you get the green answer, you're getting that A. Do you understand what I mean? That is what grades truly should be trying to reflect. Pardon me?
How would we know to do that if we didn't?
Well, you know that you're not supposed to have decimals in Imperial, right? Now, I talked yesterday about, actually, I didn't talk with you guys yesterday because you're a day behind. When we get to big distances, I don't care as much, right? Because miles break down into yards, feet, inches, right? If I told you I was running 10 and a bit miles, would I want you to tell me, I'm running 10 miles, 800 yards, 350 feet, 4 inches? No. Would I be happy with 10.3 miles?
Yes.
Yes. Everybody understand? Yeah. Now the question, Ariane, is not when will you know, it's what makes sense, right? If you have an understanding of how the numbers are working, that shows you've been paying attention, we've been talking, and that shows me you're getting what is happening. Everybody with me? Sweet. So this next one's nice and easy. There's no tricks with number 5. I'm starting with 2016 inches. And I like to write inches because then I told you I would, if we have time, I'll show you a funny gag from a movie where those quotation marks messed everything up. And I want feet. So what's in the numerator spot? Feet. What's in the denominator spot? Inches. And what numbers go in there? We're at inches and feet now. Find it on the chart. 1 foot and 12 inches. We get rid of the 1. We've got a denominator. So is it multiply or divide?
It's divide.
Divide. 2016 divided by 12. And the answer is 168. 168 what? Feet. Or FT. I don't care which one. Everybody cool? Now, here's a good example. 4.2 miles. So we're just going to leave it as 4.2 miles. and we're going to convert it to feet. I want feet. I have miles. I go to my list. I see 1 mile is 5,280 feet. I get rid of the 1. Is this a multiply or divide situation?
Wait, what?
Find it on the chart. And it's a multiply situation. So it's 4.2 times 5,280, which is going to be like 22,000 something. Whatever it is. Is everybody cool? And it's easy, right? It's one step. Because I don't make you memorize any of these conversions. You've got, that one I don't think has batteries, but you can try. Check it. 76 feet. Excellent. Okay, now we're going to stop for a moment right there because like I say, I want to make sure I cover both things that we're doing. Is everybody moderately comfortable with working within the same system? Yeah. Good. Try these 4 and then stop. Do not go on to 11. I'm going to make 11 part of the work that you're going to do in a few moments. So do 7, 8, 9, 10 and make sure you're cool with it. Number 10 is going to cause you trouble. You'll see when you get there. So just do 7, 8, 9, 10 for now. Yes, Jeremy.
You're saying this isn't work.
What?
You're saying up to 10 is not work.
Up to 10 is notes. Actually, more of this would be notes. I would do more notes if we weren't behind a day. But that's not your fault nor my fault. That's because we had that grade assembly. Pardon me? To do 4 questions? No, you don't need to move around the classroom to do 4 questions because I'm about to do some more notes with you. It's 4 questions.
Hey, don't answer them for us.
Wow, that's a big number.
Indeed it is. What is that number with 7? Because I can't do that in my head.
It's 189,000.
Thank you. Now, what is the problem with 10? Why? It's not on the chart, is it? Because it's a stupid measurement, isn't it? We would never measure 17.2 millimeters in kilometers. That's a math class question, isn't it? That is there exclusively to show me that you can figure it out. Now, Jeremy?
If we take it into real life terms, then the answer is 17.2 millimeters.
Of course. But I want to see if you can convert it. Now, you can't go... Sorry?
That is converting it.
No, it's already 17.2 millimeters. I want to know what that is in kilometers. I know it's stupid. I'm with you. But it shows me that you can work the math. Now, your chart gives you millimeters to centimeters, centimeters to meters, and meters to kilometers, right? So if you do it 3 times, you're going to get there, aren't you? So if you set it up once, you're going to be okay. We started with 17.2 millimeters. So what's the next one that we know we can get to? Centimeters, right? So we're going to set it up once. So we want centimeters. So it's 10 centimeters equals 1. Sorry, other way around. We want centimeters. 1 centimeter equals 10 millimeters. Right? But we don't have that on the chart. So we got to go step by step. Now, you're smart people. We are going from meters, millimeters up to kilometers, yes? And on that first step, is it a divide or a times? It's a divide. So we know on the first step we got to divide by 10, yes? And then we need to go from, we're going to have centimeters, but then we need to go to meters, yes? So we're going up another step, so we must be dividing by centimeters to meters is how big? Is it 10 or 100? It's 100. So I'm going to need to divide by 100. Then I'm going to need to go meters to kilometers. What's that division? 1,000. So I need to divide by 10, 100, and 1,000. And I'm going to get the right answer. See how you only have to set it up once and you can keep it going. Okay? Now you could do the same thing with Imperial to go miles down to inches. You could go miles, yards, feet, inches, all in one row. Is everybody cool? So, the ones all disappear, right? So, the ones all disappear. So, I end up with 17 divided by 10, 17.2 divided by 10, then divided by 100, then divided by 1,000, and I will get my answer. And again, sorry Dan, I don't mean to interrupt. It's a stupid measurement. Yes? Yes, some of you, I'm going to talk about that in a minute. That's why I have this question here. Dan.
Well, why don't we add all together, 100 times by 100 and times by 10?
Yeah, you could. You could go 1,000 times 1,000, which would be 17.2 divided by 1,000,000. It would still work because there's 1,000,000 millimeters in a kilometer. Everybody cool? Now, if you punch this into your calculator, some of you will get a long decimal with lots of zeros. Some of you will get this, 1.72 times 10 to the negative 5. Right? All that means is this decimal moves 5 spaces this way. And there's zeros in the holes. That used to be in Math 8. I don't know if it still is because I don't teach Math 8. That was called scientific notation. Do any of you remember seeing that? Oh, yeah. Yeah. Some of you will have. It used to be in Math 8. I don't know where it is now. But that's all it is. So if your calculator does something crazy like that, then it's whatever is on the screen, and the decimal moves. If it's negative, it moves left. If it's a positive exponent, it moves right that many spots. And zeros fill the holes. It is 0.0000172 kilometers, which again is a stupid measurement to measure in kilometers. But in metric, we can do that. If you stood up, you moved 17 millimeters. Everybody cool? And it's only there to make sure that you can. So it gives me a chance to show you converting through a few steps. Everybody good? All right, we're going to stop for a moment with your books, and you're going to turn all the way to page 23. Now, if something happens once in math, what can you guarantee will happen for the rest of eternity? The same thing. So, when we converted within our systems, we started with a value, we multiplied by a fraction of what we want over what we have, yes?
Yeah.
Jeremy.
What do you mean page 3? That's not page 3.
I said page 23, Jeremy. That's okay. Go on up to page 23.
Yeah.
That's okay. I can speak louder. I very rarely have people tell me I need to speak louder, but I will. We had value multiplied by the fraction of what we want over what we have, yes? That was when we were converting within systems. Please notice we are still converting. So what are we going to do? the same thing. We're going to have a value, and we are going to multiply by what we want over what we have. Except now the numbers are going to be ugly. If you look on your sheet, and those of you that did not get a sheet, I apologize. If you look on your sheet, you are now looking at the middle section, because we are going to be working on imperial and metric. Okay? Now here's what I'm going to do. I am going to go ahead and take a copy of this. And I'm going to bring it to where we are currently working. So we have it there, in case you don't have the sheet. So, the question, again, I have values. I have 19 meters, and I want feet. So how do I set it up? Do I have a value that I am starting with? 19 meters. Do I have a value that I wish to go to? Jeremy?
First, you bring your meters to your centimeters, then your centimeters to your feet.
Absolutely correct. Now, the reason Jeremy is saying that is because if I'm not mistaken, your people's chart does not have that. Your chart says 1 foot equals 30.48 centimeters, yes?
Yep.
But we're all aware that 30.48 centimeters is 0.3048 meters, because the decimal moves twice, right? It's just two different versions of the same chart. Sometimes they gave that chart, sometimes they gave that chart. I just took it off an old provincial exam. So these are the same.
Why isn't that one on our book?
Because it was a very small detail that I didn't notice when I printed the two. But they're the exact same thing, because 30.48 centimeters is 0.3048 meters. They are exactly the same thing. So, what I want is feet. What I have is meters. Now, if you have my chart, you can just go straight, can't you? But if you have your chart, like Jeremy said, you could go centimeters to meters, or you could do this conversion in your head, because you all already know that to go from centimeters to meters, we move the decimal place how many spots? 2 centimeters, right? So let's use mine, because I actually have it here. And you, of course, have both of them. On page 17, you have the meters, and on your extra chart, you have the centimeters. So you actually have both available to you. Yes, you do. You can doubt it all you want, or you can turn back to page 17 and see that I am right. That's okay. So where does the 1 go? With the feet or with the meters? The feet. And where does the 0.3048 go? Now, what do I do with the 1? I take it out because it's useless. And is this a multiply or divide situation? Divide. And I just punch that into my calculator exactly as I see it. 19 divided by 0.3048. And then you give me an answer. To the nearest foot. So no decimals.
No decimals, no inches.
No decimals, no inches. And you will find that it is indeed, as Ariana has said, 62 feet. Is everybody good? Austin? Of course you can. Get used to it now. Number 2. Hannah is American. How do I know Hannah is American? How do I know Hannah is American? She's using miles. How do I know Farron is one of the other 197 country citizens? Because they're using kilometers. I'm guessing Farron is Canadian because they're meeting in Emerson, Manitoba. Why you would ever want to meet in Emerson, Manitoba that's up to you. But I've never been to Emerson, Manitoba. Maybe it's a lovely town. I don't know. Winnipeg is a pretty lovely town. Sometimes.
Actually, no, Hannah is in Canada and Farron is in America. I think.
No, I see what you're saying. For the directions they drove. But since Hannah measures in miles, she must be American.
Oh, because she drove north.
But
which is this way.
that was... You get out of my brain, Jeremy. That's the next thing I was going to talk about. It's like... Did any of you go to the presentation today? No. It's like I have the chip in my brain and he's hacked in. Stay out of there. That's my brain.
What do you mean?
We saw a presentation today.
Why didn't
I
some-
went,
Yeah,
but
our
it was
class
too
didn't
busy,
go. I think
so
she
I
did.
went to the learning center.
It was pretty neat.
No,
I enjoyed it.
really wish I had went.
Now, the question I ask you is how many conversions do I have to do to answer this question?
2? Right?
I only need to do one, don't I? If I convert miles to kilometers, can I then compare it to Farron? If I convert Farron to miles, can I compare that to Hannah? So I only got to do one.
But kilometers isn't
Which one do you want to do? What do you need, Gervir? No, of course not. Somebody's out of the room. Don't waste my time and don't waste the class's time. Got it? Maybe. Everybody good? So which one are we going to do first? And the question then becomes, does it matter? No. One is going to be multiply, one's going to be divide, isn't it? Okay. Which one is going to be which? If I'm going 62 miles to km, or I'm going 98 km to miles. Where do I get the numbers? They're right on my chart here. Where does the 1 go if I'm using the black one? Goes with the mile. And what goes with the kilometer? 1.609. Is this a multiply or divide? Multiply, because the denominator is a 1. So that's going to be 62 times 1.609.
that MI?
MI, yeah, it should be MI, not M. Yeah, MI, yeah, for miles. Now in the other one, the 1 is still with the miles, the 1.609 is still with the K, but this is a division. Who drove further? You only got to do one of them. Hannah drove how many kilometers? Something like 99, isn't it? 99.7. And Farron only drove 98. So Hannah drove further. Is everybody with me? You see how it's the exact same thing if we're between systems or inside of systems. The math is one step. The only thing that's difficult is if I were to make you memorize this. Am I making you memorize it? No, it's all on your chart. Go. And don't bring your phone out again in my class or it's mine.
Then I need a calculator.
If you need a calculator, right now I only have one to lend out because all my other calculators have dead batteries.
Did you divide the 98 and
If you were doing the blue one, you would have done division, and that would have gotten you miles. And you would have found that it was less than 62.
oh, so you don't know the answer.
I didn't do the answer because people only offered me this answer.
It's way
There you go. Now be careful with this one, Jeremy. Sometimes it gives the answer as a fraction. If it does that, if you push that SD button, you'll get the decimal.
68.9.
Yeah, okay. Which is still less than 62. All right, in number 3, what do I have to convert? I got to do feet and inches to centimeters. So, could I do the feet, then the inches, and then add them? Is that okay? Yeah. Could I do feet to inches, add the inches, and then convert to centimeters? Does it matter which way I do this? Who decides how to attack this question? You do. There is no right or wrong way to do this, as long as you are doing some conversions.
It only shows 1 foot converting to
1 foot to meters. But we know that meters to centimeters would move that decimal 2 places. And if you look on your sheet, it's in centimeters. So, what way do you wish to do this? I personally, if I were doing this, I would take that and go 6 times 12 to get 72 inches. Well, I'm converting feet to inches. Then what do I do with that 2 inches? Add it to get what? 74 inches. Now, I need that in centimeters. So I'm going to multiply by what's our fraction? What goes on the top? Centimeters. And what goes on the bottom? Inches. And where do I get the numbers to fill it in? From the chart. Where does the 1 go? With the inches. What goes with the centimeters? 2.54. Is this a multiply or divide situation?
Multiply.
Why is it multiply?
Because you take away the 1.
Because the 1 disappears and they're both numerators. And what is the answer? It's like 188, isn't it? I don't remember. 187.96, so 188. We're going to do one more together, and then I'm going to let you guys go for the last half hour. I'm going to give you a little bit of work in class. Yeah, I said go. Oh. Well, that was from the first part of the lesson when I turned the inches to feet. Right? Because that is 12 over 1. Now, normally, you guys would have had a bunch more practice on this, but you're a day behind, right? So I'm kind of cramming it together. Everything will be cool, though. That's why I've moved your quiz, so you can have an extra day to practice this. Everybody good? Now, let's do this last one. Again, a real-life situation. I know my truck is 3.5 meters high because I'm a Canadian truck driver. I'm driving in the States. I got to drive under a bridge. In America, how do they measure heights? One sec, Jeremy. I see you. I'll get you in a sec. In feet and inches. So I'd better be able to do my conversions, yes? Go.
Actually, the train bridges and all that we drive under in Canada, or at least in the Abbotsford area, have the measurement in feet, not in meters.
No, they have it in meters, my friend.
Oh.
Guaranteed. I know this because every time I drive to Vancouver, by the one by exit 66, there's that low bridge that's 4.4 meters. And if you look at the concrete on it, it's chewed up. You know why? Because trucks keep driving into it all the time. And it's very, I shouldn't laugh at it because it's not, it could really hurt somebody. But as long as nobody gets hurt, it's kind of funny when the truck drives in. That just happened in Chilliwack. A truck drove under one of the overpasses, and it was just under enough to shave off the top of the truck. It was able to keep going. The top's gone. Yeah, it was in the ditch for like a month and a half. It took them to get rid of that trailer. And the whole back was gone because it peeled back like a tin can and then peeled off the back. All because some guy wasn't able to, I shouldn't say guy, could have been a female truck driver. All because, but it's not their fault, because if you went to that presentation today, you know the earth is constantly changing and all those heights aren't necessarily right. So you should never take a risk. So let's check. What do I need to convert? I have 2 choices here, don't I?
Yeah. Meters into...
I could go meters to feet and compare here, or I could go feet to meters and compare here. Who makes that decision? You do. Can I tell you the exact way to go about doing this? No, because you're going to do one of those choices, right? I'm going to tell you right now, I would use the meters because I like dealing with the decimals. I don't like dealing with Imperial if I can avoid it. So I'm going to go 3.5 meters, and I'm going to convert that to feet. And I know from my chart that 1 foot is 0.3048 meters. So where does the 1 go? With the feet or the meters? The 1. Look on the chart. The 1 is with the foot. And the 0.3048 is with the meters. What do I do with the 1? Cross it out. Is this a multiply or divide situation? Divide. And I just do that on my calculator like I see it. Everybody try it. Tell me the answer.
Because if you replace the 1 with the...
Whoa! How'd you do that?
What, the calculator?
11.48.
Right. So my truck is 11.48 feet. Now, we don't like decimals, do we? Is 0.48 pretty close to 0.5? So is my truck basically approximately 11.5 feet? And isn't 0.5 of a foot 6 inches? So my truck is 11 feet 6 inches. Should I drive it under that bridge?
Where did you get the 0.5?
Should I? No, wait, wrong question. Can I drive it under the bridge? Should I drive it under the bridge?
No.
It's a 3-inch gap. It's somebody's stolen all my rulers. It's that much. Go for it, right, Joseph? Balls to the wall, man. I'm giving her.
Actually, there might be a person clinging to the top that didn't get in trouble.
Yeah, just in case you got a stowaway, some guy Indiana Jonesing on the top of your truck.
You gotta think about that.
You got to think about that. It could happen at any time.
And you gotta give them an extra.
Now, I will tell you guys a funny story. In Cleveland, Ohio, I think, a guy drove a truck into a tunnel that had a sign, and he was wrong, and he got stuck because in the tunnel they had pipes. And he fit in the tunnel, but then he hit the pipe. And he got stuck on a super major street in the middle of the tunnel. And everybody's like, oh my God, what are we ever going to do? What are we going to do? And nobody, well, we got to take apart the pipe. We got to take him out. A little kid figured it out. What'd the kid say to do? It's stuck, dude. It's like when you put your head through the banister. It doesn't come out.
Butter?
Nope. It was stuck.
Oil?
Nope.
Bracket.
Nope. Sarah. Exactly. They let the air out of the tires.
Then how did they get the truck?
The
out
truck
if
went...
there's no tires?
It still got the tires.
Okay.
They just drove it out on the
It
tires.
was really bumpy, I guess. But
So then anybody could do that then if they get in that situation.
Technically. Yeah. What? What? Pop the tires? Go ahead, Sarah. Have yourself a gummy bear. Oh, you're going to save them like in the bank? Think you'll get interest on them? I'm just kidding. Tobby. The 9 inches, that's the bridge. 11 feet, 9 inches.
Where did you get the 0.5 from?
Well, the 0.5 was 11.48, which you got in your calculator. And isn't 4.8 very close to 0.5?
48.
0.48 is 48 over 100, which is 0.5, right?
Yeah.
Okay. And 0.5 of a foot is 6 inches, right? So my truck was 11 foot 6 inches. And then all those badasses in the back corner are like, give her! And everybody else is like, maybe you should be a little more careful. No! Floor it! Although I will say, one of you back there went like this. Like you might think about it. But then I think that that person probably listened to all his buddies and plowed right through. Yeah. Okay. All right. So we're going to stop for a moment. Ladies and gentlemen, please. I do not demand that you be silent if you wish to continue to work, but I do ask that your conversations be quiet enough that I can't hear them so I don't have to yell over you as I explain these couple of questions. Zach, hit me.
I forgot. Did you say we have to go to 20 or
18 to 20. All right. The plank is 76 inches long. If you need it explained, stop me.
Wait, what?
the plank is 76 inches long. Because 6 feet is 72 inches, plus 4 more is 76.
I just did 6 feet converted into inches.
But then there's 4 more inches, because the plank is 6 feet, 4 inches.
At 6 times 12 inches
12.
over 1 feet.
Yeah, 6 times 12 is 72, plus these 4 more makes 76.
So I can't just have it as 72.
Well, no, because I wanted the whole length of the plank. You got to remember to add that 4 in. Okay? This is 17 feet. I want to know the length of the room in inches, so I'm multiplying by 12 inches over 1 foot. 17 times 12 is 170, 204 inches. The school council has 6 yards of fabric cut into 5-inch strips. So I got to get my yards to inches.
6 times 36.
6 times 36, which equals 216, right?
Yeah.
Then I got to cut that 216 inches into 5-inch strips, right? Which is what? 43.2. Can I make 0.2 of a ribbon? No, so what's the proper answer? 43.
With 1 inch spare.
Yeah. I didn't fool anybody there, did I? Good.
Why did you divide it?
Because I have 216 inches of fabric and I'm cutting it into 5-inch strips.
Okay.
Division is cutting. Now, number 14. 2 ways you could do it. I could go 2 minus 0.755. If I convert that to kilometers, yes? Or I could go 2,000 minus 755 meters. Both answers are right. It's either 1.245 kms or 1,245 meters.
Okay.
Both are acceptable.
But to do the long way, so we'd have to convert the kilometers into meters?
Mm-hmm.
Okay.
So that's right there. 2 kilometers is 2,000 meters.
2 times over
2 times 1,000 over 1. Yep. Jeremy.
Or you can do 1 kilometer, 200.
So where does this?
You sneaky. You could have done that. 1 kilometer, 245 meters. Look, I gave you your own color.
Wait, where did you get 240?
Well, that's what's left over. Answer in kilometers. This is already kilometers. Do I have to change it? Is this kilometers? So I had 1.35, 125 times, I need kilometers. So it's 1 over 1,000. So that is 0.125. And then centimeters, 40 times, I need kilometers. So it's 1 centimeter, 1 kilometer is 100,000 centimeters. So I got to move the decimal 5 spaces. So it's 0.0040. And then when you add it up, you'll get an answer of 2.4754. No, 4754. 1.4754. There.
Okay.
Yards. Do I have to touch the 12? Why not? It's already in yards, so I got to do miles first. 4 miles times I want yards. 1760 yards over 1 mile. What do I do to the 1? Cross it out. Is this a multiply or divide? Multiply. 4 times 1760 is 7,050. 40. Thank you, gentlemen. 40 plus 12, 7,052. How do I get that inches to yards? Could I leave it as a fraction? Would this be allowed? 13 out of 36. 13 inches out of 36 in a yard, is that okay? Sure. Could I also do 7,052 yards, 1 foot, 1 inch? Is that okay too?
Where did you get that?
Where are you lost? Do you understand how we got to 7,052?
You got it from adding
70, 40 plus 12, right? So all that's left is this 13 inches, correct? Well, that's 13 inches out of a total of 36 inches in 1 yard, right? So that's the fraction.
when you add 13.
The 13 inches. A whole yard is 36 inches, yes?
Yeah.
I have 13 of them. So I have 13 out of 36.
Okay.
So I could leave it like that.
Okay.
But I also know that 13 inches is 1 foot, 1 inch. So they're the same thing.
Yeah.
Cool?
Yeah.
Okay. You guys finish 19 and 20 on your own.
That's good.
We're going to do, if you're feeling confident, ladies and gentlemen, tomorrow we're going to do 21 and 21, 22, and like 25 and 26. So if you want to go ahead, go ahead. But you probably don't need to. If you're... It's totally up to you.